Hello everyone, today we are going to focus on activity 36, which covers 36.1 and 36.2, the surface area and the volume of spheres and hemispheres. Now as our warm-up today, we're going to talk about, first off, what is a hemisphere? Well, a hemisphere is half of a sphere, our kind of ball-like structures, if you will. Officially, we define a sphere as the set of all points in a plane that are the same distance from a point to the center of the sphere. A hemisphere, then, is a plane passing through the center of the sphere that divides it into two spheres. Now, our total surface area is 4 pi r squared, aka 4 area of a circle, as I like to think of that. A hemisphere, on the other hand, is 3 pi r squared. Now, you're probably asking yourself, why the heck isn't it 2 pi r squared, half of a sphere? Well, think about if we took the 4 pi r squared and divided it by 2, we would get that 2 pi r squared, but that would only be for the curved surface, the lateral area. To get that total surface area, we need to add in that circular base, which is another pi r squared. So that's where the 3 pi r squared comes from, is the fact that we have that base to account for as well for the total surface area. Now, each time as you start solving these problems, really what you're looking for is just what is the radius of my sphere or my hemisphere, because then you can just plug it into the two formulas that we talked about above, either the surface area of the sphere or the surface area of the hemisphere. So for the first one, we have a radius of 4. So when we type this in, we have 4 pi times that radius squared. And if we type that in the calculator, 4 times pi times the radius squared, we end up with about 201.1. So 201.1 centimeters squared, because it's an area. Now, in the second example, you have to be a little careful. Notice they gave us this as a mixed number, and we don't ordinarily deal with mixed numbers. We like the decimals, or we like improper fractions. So just a reminder, if you have 3/4, 3 divided by 4, that's just 0.75. So another way of saying 4 and 3/4 is just saying 4.75, because you're just tacking on that 0.75 to 4. So now take a moment, now that you know what the radius is, and calculate for yourself what the value of the surface area should be. You should have gotten the surface area if you take 4 times pi times 4.75 squared, 283.5, in this case, inches squared. Okay. Now, of course, we have to talk about the fact that they're not always going to give you the radius. In this case, we're having a spherical shaped foam orange ball with a diameter of 16. So make sure if they're giving you the diameter, you convert to the radius by dividing by 2. And then from there, calculate your surface area. 4/3 times pi times the radius squared. You should have gotten 804.2 centimeters squared. Now, you have to also be careful when we talk about number 4, where it says a hemisphere with a diameter of 3. Well, we're switching it up to talking about a hemisphere now. So we have to take, again, not the diameter that they're giving us, but the radius, so half of 3. And then our surface area for a hemisphere is 3 times pi times the radius squared. So type this one in, 3 times pi times our radius of 1.5 squared. We get a total of about 21.2 square inches. Now, my apologies on number 5. This is supposed to be a hemisphere. I don't know why the picture's all messed up, but it's a hemisphere with a radius of 17. So take a moment on your own to calculate now what the area of this hemisphere is going to be with the radius of 17. Should have had a big number on this one. 3 times pi times r squared is 2,723.8. And this time we have feet squared. Now, as we move on to the next page, just some notes with your calculator. If you are raising something to the third power, let's say for instance 9, you are going to use this caret button, and that's going to allow you to type in what power you want. In this case, we want the third, so we'd have 729 as our answer. So take a moment on your own to practice with your calculator and the caret button here to be able to find 12 cubed and 7 cubed to the third power. Should have had 1,728 and 343. Now, why are we taking a moment to pause and take something to the third power? Well, that's because we are now shifting to the volume of a sphere and the volume of a hemisphere. So for a sphere and a hemisphere, it is really, really important that we have the formulas, and notice that these are to the third power. Well, whenever we take the volume of anything, the units are to the third power. So this makes a little bit of sense for us. Now, why is it 4/3 and then 2/3 for the hemisphere? Well, think about a hemisphere is taking up half, notice this 1/2 in here, of the space that a sphere is. So when you multiply by 1/2, aka divide by 2, 1/2 times 4/3 becomes 2/3. So that's where that's coming from. Okay, now you could type these into the calculators a couple different ways. Those of you with a graphing calculator, a lot of you like to use the alpha y equals to type in the fraction 4/3. If you have a smaller TI-30 scientific calculator, you're going to be using the ABC button more than likely. But honestly, for either calculator, and this is my personal favorite, just type 4/3 or 2/3 into your calculator like so. You would just do 4 divided by 3, there's the 4/3, or you would be doing 2 divided by 3, there's your 2/3. I think that's the easiest way. Okay. Now, these are actually the exact same problems from the first page. We just now are going to find the volume as opposed to the surface area. So for the volume, again, we need the radius. So it's again 4. And then it's 4/3 pi times that radius cubed. So when we type this in, 4 times, or divided by 3, times pi times that radius value, remember caret to the third, you get about 268.1. And a reminder, with volume, it's the amount of space you're taking up, and it's cubic units. Okay. In number 2, we've chatted about this before. The radius can be called 4.75, the same way that it could be called 4 and 4/3. So we called it 4 3/4. So we'll just call it 4.75. Calculate the volume on that one. You should have had about 448.9 inches cubed. Okay. Now, number 3, we have to be careful because they are asking us for the exact volume here of our spherical beach ball. So we've talked about exact values before, but reminder, with exact values, you are not typing pi into your calculator. You are just going to leave pi with your final answer. So if our radius is 2, and we're figuring out how much air we're filling our ball with, that's a keyword we want, the volume. And the sphere, it's 4/3 times pi times that radius value cubed. So again, to find this exact answer, we're going to type everything in but pi. So 4/3 times, again, we're not going to type pi in, times the radius cubed though. we get about 10.6 repeating. And if we take this, we're going to math frac it to see that this then would be a value of 32 thirds, or again, you could have called this 10.7 if you were rounding, but I like exact answers. So 32 thirds, pi is just going to stay on the outside because we still need to include it in our answer because it's still there. We just didn't type it in the calculator. And then this is going to be feet cubed on that one. Okay. Now, last but not least, couple things here with the hemispheres when we talk about volume. Again, we have the radius, and that's important because that's what we need to calculate this volume. But this time we're just taking 2/3 times pi times our radius cubed. Okay, now notice in our instructions we're back to just rounding. So if you type this into the calculator, 2/3 pi times that radius cubed, you get about 68.6 meters cubed. Right? Try the next one on your own. Notice you're given the diameter of the hemisphere, find the volume. Well, first off, you should have calculated that the radius was at 1.5, which then when you type into 2/3 pi r cubed, should have had about 1.7, or excuse me, 7.1 inches cubed. Now, again, a key word that something is volume is talking about how much area it's, or excuse me, how much space it's taking up in the world, how much you have to fill something up. And if we're talking about a bowl shaped like a hemisphere with this radius, how much liquid can the bowl hold? Again, the idea of filling something up should equate to us volume. So we have a bowl that's a hemisphere, so we know we're going to be taking the volume of a hemisphere, and our radius is 4.5, so we're going to plug that in for that r value. 2/3 pi times 4.5 cubed, we should have had about 190.9 cubic centimeters. In our final example, we are going to talk a little bit about working backwards now because they are talking about the volume of something given the circumference. Well, again, to have the volume of a baseball or a sphere, we know that that is 4/3 pi r cubed. The thing here is, though, we are given that our circumference is 9.25. You can't use the circumference to find the value. So what we have to do instead is we have to say, okay, I know that circumference equals 2 times pi times r. And if I solve for my radius, then I can plug that in and find the value of this baseball with that certain circumference. So in order to do this, what we're going to do is we're going to start by solving for our radius given what our circumference is. And to do that, we're going to start by dividing by 2. And half of 9.25 is about 4.6. And then I'm still trying to get r by itself, so I'm going to divide now by the pi. And 4.6 divided by pi is about 1.5. Well, now I can plug into this volume formula that radius, right? We just found that this radius is 1.5, and we can plug it in, cube it, and 4/3 times pi times 1.5 cubed is about 14.1 inches cubed. Okay. Last but not least of the closures, statement, why is the formula for surface area 3 pi r squared, not just 2 pi r squared? Well, again, the lateral area covers this curved surface of our hemisphere. That would be the 2 pi r squared portion, but we need to add onto it the base for this total surface area, which is another circular pi r squared region for that total of 3 pi r squared, right? If you add these two together. So again, you have to cover the base. All right, everyone. Have a wonderful rest of your day. Thanks for listening.